All right, I had a couple of requests on section 11.2, so let's take a look at those. First problem here, we have QT measuring 12, and we have PR measuring 15. And notice something, you've got an altitude going to a base right there. We've got both the base and the altitude, okay? So remember, triangles have three bases and they have three altitudes. The area of a triangle is half the base. Base is 15 times the height. The height is 12. And let's see, half of 12 is 6. 6 times 15 is 90. So we have 90 square units for the area of that triangle, okay? RQ. So we come back, they tell us that PS has a length of 10. Well, notice that's also an altitude. Okay, so one of the big themes in the lesson videos was the idea that sometimes you find the area first using maybe one base and one altitude, and then you can kind of flip over and you can use that information to find some other dimensions. So the area with this base and this height still needs to work out to be 90. Okay, so let's call this length x here. Half that base of x times the height of 10 is supposed to be 90. And you can double both sides of the equation. You'll get 10x is equal to 180, and that means x needs to be 18, all right? So sometimes find the area and then work backwards to find the missing altitude. But remember, a lot of shapes you can find areas using different bases, different heights. Actually, when we get into section 11.3 and 11.4, sometimes different formulas as well, okay? 25, same kind of thing here. It's a parallelogram. We have a base and we have an altitude to it. We know the area of a parallelogram is the base times the height, so the area is going to be 8 times 6, which is 48, okay? We want to find the length of AX, and once again, we know that this base times this height has to give me that same 48, okay? So maybe we could call that base there, maybe lowercase x, that's a capital X, and we know that the area is 48, and that's equal to the base of x times the height of 4, and that tells us that AX is going to have to have a length of 12. So 12 times 4 gives you an area of 48. 6 times 8 with that base and that height also gives you 48. Okay. The measure of angle A. I originally was trying like trig and that kind of thing. That side isn't 8. Okay. It's shorter than 8. So I thought, I've got a side length here and I've got a side length here. I can use trig to find the angle measure. And then I realized, oh, wait a second, I have 12 here, okay? And what you're really doing here, if you take a look at this, you have this right triangle here. I'm going to draw that a little bit differently. We've got a side length here of 6. We've got a side length of 6, and we have a side length of 12. Now, if you notice, you've got a right triangle where one leg is half the length of the hypotenuse, okay? Remember our 30, 60, 90 patterns, you've got a leg that's x, and you've got a leg the hypotenuse that's 2x, okay? So this is a badly drawn picture, okay? It's not to scale. And I think in your book it's a little closer to scale, but it still doesn't really look like a 30, 60, 90 triangle. But anyway, here's the point. You have a right triangle that's following the 30, 60, 90 patterns, but be careful. The side that's half the hypotenuse is opposite the 30-degree angle. So that's actually a 30 there. This really should look more like, this, with that side being 6 and the hypotenuse being 12. Now, for a lot of you, probably goes over your head. Maybe you didn't notice that. Yeah, we're not conditioned to notice that all the time. I had trouble seeing that the first time. So the other thing to remember is we can write trig equations to find angle measures. Okay, you had a right triangle that had a side length of 12, and we had a side length of 6, and we want to find that angle measure there. Okay, so remember sine, cosine, and tangent, SOHCAHTOA. Okay, you can use those SOHCAHTOA rules. We have an opposite side and we have a hypotenuse, okay? Opposite over hypotenuse is sine, okay? Opposite is 6, hypotenuse is 12. And remember that you can use the inverse sine function. 6/12 is 1/2. And anyway, if you run the inverse sine on 1/2, you're going to find out that it's a 30-degree angle. So even if you didn't see that, remember trig, anytime you've got angle measures, trig is going to give you options to do things even if you don't pick up on some of those kind of quick mental patterns from earlier in chapter 9. Hope that helps.